Welcome everyone to the Infrared Training Center and this month's webinar on NFPA descriptions for recommendations for arc flash and the PPE that you should be wearing or potentially be wearing when you're opening up electrical cabinets. My name is Jeff Sneed. I'll be your webinar host for today. I'm also an ITC instructor. The current level that I am right now is an ITC level 3, and I've been an instructor for the Infrared Training Center since 2018. Some of my previous roles in what I was doing before I became an instructor, parts of it were performing arc flash studies, and other parts related to that would be the proper labeling of electrical cabinets. Okay. Now, what we're really going to get into is some of the labels and some of the descriptions that you're potentially going to see on the different cabinets. Okay, every panel should have some sort of indication on it, so some sort of labeling system on the different panels showing you voltage and showing you other bits of information that are also inside of that panel. Okay, these stickers are going to let you know what the specific safety information inside of those panels is. The individual labels will tell you what you need for PPE for every single panel, okay? And it's to do this, it's so you can be safe when you open up the panels. It's also important to know that each panel can contain a different level of PPE. All right, let's talk about arc flash labels. This is just one generic label. They could be different shapes, they could have different colors on them, they could be in a different setup, they could be much larger with more information on them. It all depends on the company that you purchased the labels from or the business purchased the labels from. So what we're going to do is classify and break down the individual components of an arc flash label. Okay, there's going to be really 9 key factors we're going to be looking at a minimum. They can have more than this. Okay, the first one that we're going to look at is the incident energy. Now, if you look, it says flash protection, and again, this is just a generic label. It could say whatever that it would say on the panel that you're at. This one just happens to say 6.1 for the incident energy for the flash protection. Now, what that means is it's realistically the level of the energy that someone would feel if they're working in that distance in the event of an arc flash. Okay, and we'll talk about the distances here in just a little bit. The energy is realistically, it's measured in calories per centimeter squared. Okay, if you may have heard of this before or not, kilocalories is another common term that's used for that. And what you need to do is you need to make sure that the PPE that you're wearing has a minimum rating that's at least 6.1 in this label's example or higher. Okay, always make sure to look at that number, and the clothes that you're wearing have a higher number than what the label says. That's what's really important. Now, the next thing that we're going to talk about is some of the distance. Okay, the first one that's going to come up is this thing called an arc flash boundary. Now, in this case, for this sticker, it says 54 inches. Okay, and now what the arc flash boundary is, it's realistically where the source of the arc can happen, and then the distance that arc can travel where it will reduce the amount of energy that's in the arc. Okay. Well, that number that it's trying to get to is 1.2 calories per centimeter squared. Okay, so if you were within that working distance, you can receive a 2nd degree burn. Okay, at a minimum. If you're not protected by the PPE, or if you don't have the correct PPE on that doesn't match the number that we reviewed in the number 1 section, then you have to make sure to stay outside of this boundary at all times. So an easy way to think about it is be further away than the 54 inches, excuse me. Okay. If you're within the 54 inches, you have to make sure that you are wearing all of the recommended clothing for that working distance. Now, the next thing is going to be the available fault current. Okay, this one says 29.62. This is the fault current protection that the fuse is upstream from the device. All right, so the KA number for any fuse could be whatever the fuse is that you have upstream. It's the breaking point of the fuse is the easy way to think about it. Now, what it is it could be all over the place. It really depends on what your employer has upstream from it. Okay, it could be, again, pay attention to that. Those two numbers sort of come in correlation with each other. The faster that number is or the lower that number is, then it changes the boundaries around. So as a practical standpoint, looking at it, that's how they tie together. Now the next one, what a really big one for you to pay attention to is going to be the recommended PPE. Okay, it's going to be at the bottom. Now the recommended PPE shows you all of the things that you should be wearing. Okay, so in this case, for this sticker, if we go through it, it says long sleeve shirt and pants, hard hat, face shield, and balaclava, or you could have a full hood that encompasses your head and your neck, that you don't have to wear the two-piece balaclava and hard hat, safety glasses or goggles, some sort of hearing protection that won't melt. You have to have some sort of rubberized hearing protection. NFPA does a good job of showing you the differences or telling you the differences on what of those you should be wearing or not. Rubber insulating gloves with leather protectors and leather footwear that is electrical hazard rated. Okay, at a minimum, you have to be wearing all of those things. Now, with this, it really depends on, it could have company standards as well. You could have additional PPE that's required from your company. It could say you have to put up electrical safe barriers around you. It could have blankets. It could be lots of other things besides that. But at a minimum, from an NFPA standpoint, that's what you need to be wearing. Now, working distance is up next. Okay, what this means is your physical working distance, or if someone was going to be contacting. Okay, so at the flash hazard, in this case, this one's going to be 18 inches. Now, if we're using the IEEE standard for calculating arc flash incident and boundary calculations, this is really the working distance between the arc point and where you're going to be. Okay, so you could tie in that 18 and 54 inches that's on that sticker together, and that's going to give you your typical working distance for someone who's going to be inside of an energized electrical cabinet that's going to be making contact with it. All right. Typical working distance, usually speaking, is around 18 inches, and that's really a statement that's for under 600 volts. So lower voltage equipment, it's around the 18 inches section. This could be a benefit with using thermography because we can be way further back, much further distance than 18 inches and be able to perform the inspection, but this is specifically talking about if you're going to be contacting it. Now, the next step is going to be the nominal voltage. Okay, every panel should tell you the voltage that's on the inside of it, and this one just happens to be 480. Now, any one of the voltages, it doesn't matter, it should have a label on your cabinet, 120, 280, 277, 480, all the way up to 4160. It doesn't matter. You should be able to know what the equipment is that you need when you open up that cabinet door to make sure that you have the right equipment to do the job. Make sure, it's sort of a general statement, but it talks about electrical workers and all the electricians that are there to do a job. You have to make sure, just to give an example like they give here, is using a meter on your equipment. Okay, if you're checking under 600 volts, your meter is probably going to be rated for 1,000 volts. But if you're checking equipment that's above 1,000 volts, you need to make sure that the meter that you have is rated for the voltage that you're going to be checking. You would not want to use the wrong meter at the wrong voltage cabinet. That's the way to think about it. That's why they want you to have the specific voltage on that cabinet. Okay. The next step is going to be your glove class. Okay, this just happens to be 0. The glove class realistically talks about the rubber gloves that you're going to be wearing and their shock resistance. Okay, there's different levels of gloves. Just make sure that you're wearing the correct gloves for the correct rated voltage for the cabinet. Usually on the rubber gloves, there's some sort of indication, whether it's a stamp on the glove or it's a sticker that's glued to the glove that shows you what that rating is going to be. Okay. Next up is the limited approach boundary, okay, 42 inches in this case. This talks about qualified versus unqualified workers. If you go back to the last webinar that we recorded, John Wagner, one of our senior instructors, goes into the newer edition changes for 2024 NFPA, and he also goes into the differences between qualified and unqualified workers, because that is part of NFPA's classification on who can and cannot be working on electrical equipment. Okay. The limited approach boundary talks about if you're not a qualified worker, you should never enter that boundary. Okay, so you never should get closer than that if you're not a qualified worker. Only qualified workers can get within that boundary and work on the equipment safely. The next one is going to be the restricted approach boundary, okay, 12 inches in this case. You can only a qualified person can enter the restricted approach boundary, okay? NFPA assumes if you're within 12 inches of the target of whatever that it is that you're trying to work on, that you're going to be in touching it. That's the intention, is for you to touch it. That's why they want qualified workers, only qualified workers, to work within that distance. Okay, you have to make sure that you're wearing all the PPE, including all the leather gloves and everything else that's required on the sticker. Okay. Now, let's talk about some of the PPE differences that you may potentially see. Again, it's very cabinet dependent. It could be different from one cabinet to the next. Now, all it has to do with is the incident energy that's in the panel. So what you should do is you should look at the incident energy, which would be the task 1 that we went over, and then you should also correlate that with the task number 4, the PPE that's required. Okay, and that's where this comes in. You need to tie the two systems together. Yes, you should wear the PPE, but that PPE should have the number that's above task 1, just as a review. A large benefit to using thermal imaging, thermography, is we can be well outside of these working distances. We can be really far back in some cases. Now, this is very camera model dependent on how far you can actually be away versus the size of your target, but those are some of the things that we review in our infrared training center courses. Okay. The problem or the situation that you'll find yourself in is, you're either the person that's opening up the cabinet doors who is also going to be doing the thermal scanning. Okay, that can be a problem because you can be, or you will be when you open the door, in some of those restricted, limited other approach boundaries. You're going to be really close when you open the door, but then when you back up is when you've reduced that arc energy, okay, when you get further back. So you're still going to have to wear a higher level of PPE if you're going to be the one that's opening the door, if you're within those working distances. The other way that a lot of people will do it is they'll have 2 people that are working at the same time. So there'll be a qualified person that would be opening up the panels, which is going to have a higher level of PPE required because of the distances. And then you're also going to have the other person who's going to be doing the thermal inspections who can stand further back. Okay, as long as the thermal inspector doesn't get too close, so again, whatever the panel or whatever the sticker says, then you usually get to wear let's say a less amount of PPE than all the way up really close to it. Now, different clothing, okay? The standards now are categories 1 through 4. There used to be a 0. There's no longer a 0 anymore, okay? But if we try to tie together the differences of what's happening, you sort of notice a correlation between the amount of energy that's in the cabinet and the level. If you look at the very first one, category 1, it says it's 4 calories per centimeter squared. Then we go to 2, it's 8 calories. 3 is 25 calories. 4 is 40 calories. So the easiest way to think about this is the higher that number is, the more energy that's inside of the cabinets, okay? The more PPE that you're going to have to wear, the higher that number is, okay? So if we look at the number 1, it goes through all the details of what you should be wearing. So shirts, long sleeve shirts, okay? Pants or coveralls, face shield with a hard hat, safety glasses, hearing protection, gloves, and footwear. All right. Category 2, it's pretty much the same thing overall, but it has an addition to it. Okay. It says you need to be wearing a face shield, but with a balaclava. So it's a neck covering that goes around your neck, covers up your ears and parts of your face. Or you can bypass that double layer system by using a hood that encompasses your entire face. Then if you go to category 3, the clothing actually changes. Okay, it's thicker, but what it is most of the time it's going to be coveralls or a 2-piece suit. Okay, and then the safety glasses and hearing protection and the leather shoes and all that plays a role in every single one of these. 3 and 4 are basically the same. Okay, it's the same clothes, it's the same type of clothes. The difference here is the rating that's on the clothes is different. Okay, they're thicker. The materials that they're made from could potentially be a little bit different depending on the manufacturer that you purchase the clothes from. But a category 3 would be 25 and a category 4 would be 40, even though the clothes look exactly the same. So if you have both suits, for example, if you have a 3 and a 4, make sure that you grab the proper one for the proper job. If you're doing the 40 cal suit, make sure you grab the category 4 suit. But those are things to think about. Which cabinet I'm going to be in requires a different level of clothing. Now, cleaning and care. We have to make sure we take really good care of this stuff. All different manufacturers have put out really good information on how to take care of the clothing that you purchase from them. PPE is not a cheap thing, so you want to try to maintain it as well as you can, okay? But a lot of people don't take care of their clothing in the proper way. One of the most common misconceptions in the industry is your arc flash clothing is stiff, and it's stiff and it's not very flexible. It's kind of itchy. So what a lot of people will do is put a lot of fabric softener and wash them a bunch of different times, but this would be bad. The fabric softener can potentially be hazardous. It could potentially catch on fire. And what it's also doing is it's reducing the arc value of the fabric because it's making the clothes a lot looser and stretching those fibers further apart. So what it's actually doing is reducing the arc flash value. You don't want to do that, okay? What you want to do is pay attention to the manufacturer's recommendations. Now, these are some very common quotes. There are a few bits of differences between the different clothes depending on the manufacturer. Like a 40 cal suit, you want to take care of it a little bit differently than you would a level 1, for example. But again, read the manufacturer's standards. But here are some very common things you see in the industry across multiple manufacturers. Don't use bleach or peroxide. Don't use any sort of additives, and that gets back to the fabric softener. Don't do any starch or anything that's going to be additional to it. If you can, avoid washing in hard water because that's going to be eventually adding minerals to your clothing as well. Wash them separately from other clothes. If other clothes have fabric softener on, it could potentially get on your arc flash clothing. So basically wash them on their own. It says if you want to keep the color, wash them inside out. They also talk about hot and cold water. We want to wash them anything that's too hot. Use liquid detergent. Try not to use powder detergent. And this is the temperature thing. Yeah, don't wash them in where it's too warm. If you need to soak them for a specific reason, you want to soak them, and then you also want to use non-peroxide based pre-wash. Right? Lots of companies advertise their own wash for proper care of their own equipment. So they have things that are free of dyes and free of anything that would be harmful to whatever the type of clothing is that you have. Another common misconception in the industry is if your workplace provides you with PPE that you should be wearing on a daily basis, a lot of those people will wear them and do their other maintenance tasks as well. So if you're a person who's a maintenance technician who would, let's say, get dirt or grease or some sort of oil or staining or cuts or whatever that it is on your clothing, that's going to change the arc flash value of your clothing. If you have a category 2 rated clothes and then 8 calories per centimeter squared, and then you get a grease stain on your shirt, for example. Well, the grease could potentially catch on fire in an arc flash event, and that reduces the overall rating for the clothing that you're wearing. So it's recommended by every manufacturer. If you get cuts, soiled, things that you can't properly take care of, it's always recommended to get another garment to keep yourself safe, and that's where they advertise their individual cleaners. Okay, they say you can soak them. If you soak them in their advertised cleaners and it doesn't come out at that point, then that's when you should replace. Now, this is directly from NFPA. If you want to look more of this or more of the stuff up, more of the information about the specific equipment and all the other things that are in their equipment classification, it's going to be section 250.2, okay, N70E. You can look these things up, and this is just a small amount of information that's in there. Grounding equipment, hot sticks, rubber gloves, test equipment, blankets, insulating mats, and so on and so forth. There's lots of different things that are in NFPA's equipment classification codes that you should consider in your personal protective equipment. All right. Thank you for attending. Thank you for attending. Hopefully you learned a little bit of something out of that, or at least it was a refresher for you. If you're looking for any other information about thermal imaging or understanding more about some of these topics, some of the 70E topics, whether it's, what camera do I need to be outside of my arc flash boundaries, or how do I look through infrared windows, feel free to reach out to us at the Infrared Training Center. If you log on to that website, you find all the information. We have tons of different classes all across the United States. Feel free to reach out or call or email at any point in time. We'll try to get back with you. Thanks for attending.